Starting chapter 8 today, section 8.1, variation functions. It's talking about some different types of functions and their variations. Section 8.1. A couple of vocab terms. First one is direct variation. Direct variation is a linear function defined by an equation of the form y equals kx. The key word there is it's a linear function. Okay, so linear function, what's that mean to you? What type of root word is there? What type of graph are we looking at? Line. Direct variation is a linear function. It's a line function. Okay, and it's called direct variation because what happens is we get a constant or a direct change. Okay, so that direct variation there, that linear function, is we're talking about a line function. And it's defined as y equals kx. Okay, so direct variation is that form right there, y equals kx. Okay, I got to be able to recognize that. Then we have the constant of variation. The constant of variation, when x and y are variables, you can write k equals y over x. So the ratio y to x equals the constant k. That is derived from this equation. Think about it. If I take y equals kx, and I were to tell you to solve for k, if we were to solve for k there, what would you have to do on both sides to get k alone?
Subtract y over and then subtract take k alone.
I got to get k alone. Think about it here. What's the operation between k and x? It's multiply, right? So what would I have to do to get x on the other side? What's the opposite of multiplication?
Division.
Division. So we're going to divide. Yeah, so if I divide both sides by x, does everybody see I have k equals y over x?
Oh, yeah.
Guess what? That's my constant of variation. K equals y over x. Okay, that's what that means here. So how can you find your constant? Well, you can do k equals y over x. That is your constant. Or if I have an equation like this, let's say I give an equation y equals 2x. What's my constant in that equation?
2.
My constant k is 2. It's that 2. Okay, so recognize that's the constant. That's that direct change that we have. To solve direct variation, a lot of times, because it's the same constant, to solve it, I can just use the equation or the cross products here, y over x equals y over x. And I can solve from there. So just like we did on number 1, we can solve these problems. So direct variation here, the variable y varies directly as the variable x if y equals kx for the same constant x. So we're going to look at problems like this today, where it says if y varies directly as x and y equals 52 when x equals 4, find y when x equals 6. Well, I can just solve that as y over x equals y over x. So for instance, y equals 52 and x equals 4. 52 over 4 equals, find y when x equals 6, y over 6. 52 over 4 equals y over 6, and then I can use cross products and solve, and when I do that, I get y equals 78. Guess what? That was our warm-up problem. It was just set up for you already. So you've already actually solved this problem without even knowing it. Okay? The big thing here is it is direct variation. Now, if I wanted to find my constant, let's say I wanted to find the constant here. Well, I'm just going to divide 52 divided by 4. My constant, k, equals 13. Okay? So I can just plug that in and do the same thing, and I can find that constant. All right? They take you through an algebraic way down here. They're using the equation, so you can use the equation, plug it in, find your constant, and then plug that into an equation, and then plug x in and solve. It's a little bit more of a process there, I'd think. Okay? But both ways actually work to give you the answer. We also have joint variation. When you think of the word joint or joining, what do you think of? Putting together. Something's like joined, right? So joint variation here, y varies jointly as the variables x and z. So now that's saying y equals k x z. So x and z are joined together. Okay, so I have two variables there. And it's really the same thing. The only difference here is instead of saying y over x equals y over x, remember x and z are together. So we're going to say y over xz equals y over xz. And I can then find my joint variation there. or I can find the constant variation and then find x, y, or z from there. Okay, so joint variation, notice the x and z are combined. All right, let's take a couple seconds and try these two on your own, or together. If y varies directly with x, and y equals 30 when x equals 20, find y when x equals 50. Okay? So varies directly. What's it mean to vary directly? Well, that means we have y equals kx, or y over x equals y over x. Okay? So if it varies directly, I'm going to say 30 over 20 equals y over 50. Does everybody see why it's 30 over 20? Does everybody see where I get the 30 and the 20? Because it says y is 30 when x equals 20. So find y when x equals 50, so y over 50. Now I'm just going to use cross products to solve. What's 30 times 50? 1500. 20 times y? So I have 1500 equals 20y. And if I want to solve for y, what are you going to do on both sides? Divide by 20. So I can cancel 0 out to make this easier. What's 150 divided by 2? Y equals 75, not 50. Y equals 75. Okay, there we go. 2. If y varies jointly as x and z. Okay, what's it mean to vary jointly now? Well, that's like saying y equals kxz. Or I'm thinking as y over xz equals y over xz. And it says y equals 150 when x equals 2.5 and z equals 12. Find y when x equals 4 and z equals 6.5. So I'm going to set this up as proportions. 150 over 2.5 times 12. Does everybody see why I have 2.5 times 12? Because it's jointly, I need to put the x and z together. Equals y over 4 times 6.5. And then I can solve from there. So I'm going to do some multiplication here. What's 2.5 times 12? What's 12 times 2? What's half of 12? So 24 and 6 gets me. So 2.5 times 12 is 30. Does everybody see I can do that mentally? Equals, let's do the same thing here, y over 4 times 6.5 or 6.5. What's 4 times 6? What's half of 4? 24 and 2 is 26. Okay, and now I can use cross products to solve. Somebody asked a great question earlier. They said, well, can I simplify 150 over 30 first and then solve this? Yeah, I can do that. So 150 over 30 really becomes what? Yeah, isn't that just really 5 over 1? Yeah, I can make that an easier problem, make that 5 over 1. So 5 over 1 equals y over 26. I end up getting y equals 130. Nice job. So again, I can set these problems up to make them easier if possible. Same idea. Take a couple seconds. Try these 3 on your own. So 3, suppose y varies directly with x. X equals 27, y equals negative 51. Find x when y equals negative 17. Katie, set that up for me, please. I bet you did. Try it.
Which one is it?
3. Jake King, you think you got it? Set it up for me.
Negative 51 over 27 equals negative 17 over x. I did that.
And when you do that, you get x equals?
X equals 9.
Nice job. Katie, is that how you set it up? Oh, because it's y over x equals y over x. So make sure you have your y on top.
Oh, you have to have your y.
Gotta be consistent. Yep. 4. Y equals 4 and x equals 3. Find y when x equals 6. Oh, I don't know. Let's go with Hannah. Set that up for me. What'd you do?
4 over 3 equals y over x.
And when you do that, you get y equals?
8.
Nice job, Hannah. 5. Y equals 7, x equals 2. Find y when x equals 8. McCool, what do you got there, bud? Set it up for me, please.
I did 7 over 2.
And you got y equals 28?
Yeah.
That is correct. Nice job. Nice job. Last thing we're talking about is there's also this thing called inverse variation. Okay? What does direct mean to you?
Direct. Straightforward.
Straightforward. Okay, so direct variation kind of makes a straight line, right? What's inverse variation mean to you? Kind of inverse means going like
Backwards.
or kind of like not directly, right? Inverse variation gives this graph something like this. Okay, so you get two graphs that kind of go opposite different ways. They're curved. That's kind of inverse variation. Now notice direct variation is y equals kx. Okay, that's direct variation. Indirect or inverse variation is y equals k over x. So as you look at this, what can x not ever be?
0.
0. Why? Yeah, you can't ever have 0 in the denominator, right? So that's what actually what we get here is called an asymptote at 0, because x cannot ever equal 0. Okay, you get these asymptotes right here through your graph. If y varies inversely as x, okay, and y equals 4 when x equals 30, find y when x equals 20. Well, let's think about it this way. If I give you y equals k over x, and I were to tell you to solve for k, what are you going to do on both sides to get k alone? And multiply by x, right? So what we have here is k equals yx. Well, if I were to solve for these problems, instead of saying y over x equals y over x, which is what we did for direct variation, we're now going to say yx equals yx. Okay? So because it's inverse variation, yx equals yx, if I have a problem like this, y equals 4 when x equals 30, so 4 times 30 equals, find y when x equals 20, y times 20. 4 times 30 is 120. 120 divided by 20, I get y equals 6. Okay? Or again, I could use their steps, plug it in, find the constant, take that constant, plug it back in, and then plug my equations in. It just takes a little bit longer. Okay? I can also graph these functions. So to graph the inverse variation function y equals 120 over x, make a table of values. Now, when I make a table of values here, what x value can I not pick? What was it? Yeah, x cannot be 0. Okay, x cannot be 0, so recognize that. Okay, x cannot be 0. Now, we always want some negatives and some positives. Why did they pick the values they did? Like negative 10, negative 20, negative 30, negative 40. Why did they pick those values? Why not like 1, 2, 3, 4? Because why, Jake? Yeah. Okay, if you think about it here, the number like 120, I don't want to pick numbers that are easily divisible by 120 there, right? It makes it a lot easier for me to graph, but then also I want a good range of numbers. So again, I'm going to do the same numbers, negatives as positives. I want a range of numbers. X cannot equal 0. Okay, and recognize here inverse variation. My graphs are curved. It's called a hyperbole. 6. If y varies inversely as x, okay, y varies inversely as x, so that means y equals k over x, varies inversely. And y equals 2 when x equals 9, find y when x equals 6. If I were to set that up and solve, I would say 2 times 9 equals y times 6. So what's 2 times 9?
18.
So I get 18 equals 6y. So what's y going to equal?
3.
So y would equal 3 there. Okay. So we found that. And then it says to graph the inverse variation function. Well, to graph it, I need to find the constant. Who knows what my constant here would be? Remember, if I wanted to find k, I solve for k, right? So I take x times y. Well, we already did that. What's x times y? 18. So I'm going to graph y equals 18 over x. Now, as I look at this, I need to pick some values of x. What are some good values of x to pick here? I'm going to make a table of values. What can I pick? You said 1. I agree. 1's a good one. What's another one? 2's a good one. What's another one? Why not 4?
All three.
Okay, 3 is a good one. What's another one besides 3? 6. Let's just do 1, 2, 3, 6. I like those numbers. Again, why do I pick those 4? They're all divisible by 18, right? So if I take 1 and I plug it in for x, what do I get for y? 18. If I take 2 and I plug it in for x, what do I get for y? If I take 3 and I plug it in for x, what do I get for y? If I take 6 and I plug it in for x, what do I get? Okay, now I'm going to do the same thing. I'm going to do negatives. So what are some good x values that are negative to pick? -1, -2, -3, -6, right? So take -1, plug it in, and I get -18. Take -2 and I plug it in for x, and I get -9. Take -3 and I plug it in for x, and I get. Take -6 and I plug it in for x, and I get. So I'm going to graph these functions here. I have 1, 18, 2, 9, 3, 6, and 6, 3. What else about my graph here? It's curving down. Then I'm going to do the other side. -1, -18. -2, -9. -3, -6. And -6, -3. Same thing. I got a graph going the other way. So that's how I can graph. Take a couple seconds, try these two on your own. A is just ask for the constant. B, is it direct or inverse? C and D, plug some values into the equation there and see what you get back out. Take a couple seconds to try these two on your own. So number 7, what's the constant variation here? King, what's the constant?
5.
Very good. It's 5, yeah. Constant's going to be that part right there. Jace, is this direct or inverse variation? It is direct. C, if y equals 10, what's x going to be? McCool? 2. X would be 2. Yeah, if you plug 10 in for y, you get 10 equals 5x. 5 times 2 is 10. D, if x equals 7, what's y? Hannah, if x equals 7, what's y going to be? So take 7, you plug it in. What's 5 times 7?
35.
Yep, y is going to be 35. 8, what's the constant variation there, Drew? Yeah. Constant's 2. B, is this direct or inverse variation? O'Connor? It's inverse variation. C, if y equals 4, what's x? Tough question here. Who thinks they got this one? If y equals 4, what's x going to be? Anybody got it? It is a fraction. It's a half. Nice job, Katie. Yeah, x is about to be a half. So what happens here, you get 4 equals 2 over x. Well, I multiply both sides by x. So I have 4x equals 2. And then divide by 4. And you get x equals 1/2. Okay. And D, if x equals 1, what's y?
2.
2. Nice job. Here's your assignment.